everybody. I think we'll get started in the interest of everybody's time. And I really appreciate you coming today. So it looks like we have the right mix of folks here. We've got a lot of folks who are using AWS. We've got some folks who aren't using it and some folks who don't know. So we'll see how that works out. And hopefully we're in the, we're going to provide some interesting stuff for you and some stuff of value. I really appreciate everybody joining us today to talk about AWS and really how it's impacting our careers as network engineers or networking folks. So just before we get started, a little bit about Sunset Learning. We've been developing and delivering training since about 1992, and we recently became an AWS authorized learning partner. So along that path, we've really spent a lot of time helping our customers and ourselves learn a lot about the IT industry and a lot of the changes that occur that create big transitions in really our industry that impact our careers. And so Greg and I really wanted to talk to you a little bit about how this particular transition, which started several years ago as far as the virtualization of network infrastructure and network types of functions towards infrastructure as a service provided by cloud providers. And we felt that it would be interesting to you folks in helping you, like it did us, broaden our horizons as far as our understanding of the breadth of AWS services and how you can maybe use those services to solve some of the business challenges you have today with your on-prem solutions. So with that, let me have Greg introduce himself, and then I'll tell you who I am. Greg.
All right. Thanks, Vic. Good morning, everyone. My name is Greg Mills. I'm also with Sunset Learning Institute. And as Vic said, we've recently moved into the AWS training partner world. So we're happy to start sharing this kind of information and also some AWS training courses in the future with you all. So I have been, in the training business since 1997. So what's that, 24 years or so? In addition to being a trainer, I'm also been doing a fair amount of consulting. I manage a team of engineers inside of a large company as part of Sunset as well. So again, we're just kind of looking forward to sharing this information, and this is just getting us going with AWS. So thanks for joining. Vic, back to you.
Thanks, Greg. And yeah, I'm Vic Tagawa. I'm the Chief Technology Officer here at Sunset Learning. And I've been in and about this training business since the beginning, since about 1992, and have held various other positions as a consultant as well as working for other organizations. And it's just not very often we see these big inflections that occur in the technology world that are highly impactful to the types of work that we do as network engineers. So it's one we thought we should pay attention to. We're very excited to be an AWS learning partner. And with that, I think we'll move forward. Our objectives here are really to talk to you about the different AWS services, kind of expose the breadth of them. I think when I first looked at AWS or heard about AWS and thought about it, I thought, that's just some compute stuff in the cloud for developers. But over time, we learned a lot more about that and about the depth of services, and we're going to look at that a bit. We'll talk about some of the key infrastructure services, although there's many more other than infrastructure. And hopefully this will help you develop some use cases for AWS in your environment to solve your particular problems. And also maybe think about the impact of cloud services on your careers. And obviously, we're not here just to provide a webinar. We'd like you to sign up for classes through Sunset Learning. So of course, we'd like you to learn more about AWS through us. So
Vic, let me, if you don't mind, let me just interject. You're all muted. So the one thing that we do want to ask is if you have any questions, go ahead and use the Q&A panel or even the chat panel, and we'll try our best to answer your questions.
Thanks, Greg. I appreciate that. I always forget that one. All right. On our agenda, we're going to talk a little bit about the cloud. We'll talk about what AWS is and really AWS as an infrastructure provider in this session. And we'll look at a few of the key services. We'll talk about the Elastic Compute Cloud, or EC2. Greg's going to talk to you about storage options and database support. And then we're going to wind it up by talking a little bit about automation. And we don't want that to be scary or anything, but I know we all hear a lot about automation, programmability, Python, Kubernetes, and all of this stuff that maybe traditionally us as network engineers have a hard time figuring out how that plays into our world. But I think this idea of cloud services and using cloud services is a nice stepping stone towards that area of automation. And so I'm going to give you a little demo there as we get there. But before we get started, I want to I'm not going to poll you to death, but I thought I'd throw a poll up here, a different poll. Sorry. It's not that one. When you think about the cloud, what's the first thing that comes to mind? Just take a few seconds, maybe click on there. This is a multiple choice question, I suppose. So let it be the first thing that comes to mind. Wow, look at that. There's some interesting stuff coming in here. All right, excellent. So I'm going to show you guys the results. So I think it's kind of interesting. So some of you folks said rain, and I think if you said rain, you're definitely in the right place today. A lot of you also chose some of the other options, and I think that's fantastic. It's a good lead in to this next slide that I'm going to bring up here. And really, as we talk through it as technologists, a lot of these terms come up, whether it's compute, scalability, elasticity. Did I have elasticity on there? I don't know. Automation, speed, security, these things. And when we think about those, it's we kind of wonder maybe how that manifests itself. How does that really happen? I think I saw scale a lot on there. And so we'll look at that as we go through here. But at the same time as you're thinking about these things, bear in mind that our executives and our leadership hear these things, right? They're barraged by this, whether it's at trade shows, through magazines, et cetera, right? Pay as you go, CapEx to OpEx, focus on your business, lower your cost, unbridled growth, first to market, those types of things. And that's great. We want to provide all those things to them. And what we should really be thinking about is that no matter how we present these services, whether it's on-prem or through the cloud, there's a lot of complexity involved, and we have to think through and plan exactly the same way for cloud services as we do for on-prem services. So for us, that's great job security. So let's take a look at this a little bit more. As I mentioned to you, when I first thought about web services, whether it was through Amazon or Azure or Google, et cetera, I kind of thought, that's a programmer's thing. There's some compute stuff up there. They can use that. They can play around with it, and everything's great. What I really didn't realize was the breadth of services provided by Amazon and AWS in general. And when you look at the number of services that are provided, you start getting an idea that there might be more to this thing than just compute services. And even when we look at this compute option, there's many here. So as we go forward, Greg's going to take us through, and he's going to show us a little bit about AWS infrastructure and talk through some of those things we traditionally think about on-prem and the additional things that AWS adds to that. So, wow. Seems to have a slide coordination problem. There you go, Greg.
All right, thanks, Vic. So Yeah, everyone, if we take a look at the picture here on this particular slide, probably as a network engineer, we probably run across pretty much all these components. So of course we have our subnets, whether they be public subnets, which might otherwise be known as DMZs, where we have public facing servers. We probably have some private subnets where we have our internal application servers, maybe even servicing those web servers that are out there on the public subnet or DMZ. We may or may not have load balancers already in place so that we can distribute the load across either our external facing servers or our internal facing servers. And of course, we have databases that we might be tying into in the private subnet. We probably have some kind of data storage out there that we're gathering information and maybe saving files or whatever we're using it for. And then a lot of us, we have a NAT gateway over on the upper left of, or the upper left, or the left side of the public subnet there. I'm sorry, I can't point because I'm not presenting. Thank you. So that NAT gateway is, of course, doing address translation for us to get us out to the outside world, off to the internet, without having to use public IP addresses for everybody. And we probably also have an internet gateway, correct? Because that's what's providing us access to the internet. Now, the internet gateway and the NAT gateway, they may be the same box. They may be the same device. Well, the good news with AWS, if you're not already familiar with it, go ahead and click, please, Vic, is we can bring all those components, click, please. You're spoiling my easy flow. All right. We can bring all these components into AWS. And so a lot of these things haven't changed. So I still have my internet gateways. I still have my load balancers. I still have my NAT gateway to allow maybe my private servers to get off to the internet if that's something that I desire, other than the ones that are already on the DMZ, which in AWS, we referred to that as a public subnet. But we can park all of our devices or a lot of our components into something called the virtual private cloud. And so up there on the top left, you see the little cloud thing. Our private subnets, our public subnets, they all fit inside of our own little space, as I call it, our home away from home inside of AWS, the VPC. So as you instantiate components, a lot of them sit inside the VPC. You decide whether they go into the public subnets, and you can have more than one. You decide whether they go into the private subnets. You can have more than one of those as well inside your VPC. So we still have the same architecture. We still have the same componentry. But one of the cool things about going into AWS is we get to take advantage of a lot more of their capabilities, a lot more of their services. So on the upper left there, Amazon CloudFront, if we want to do a content distribution network, we want to have our componentry out there close to where our customers are located. We take advantage of Amazon's worldwide network. All right. Amazon Route 53, DNS. And of course, we're probably all familiar with DNS servers to do name resolution. But we can also use Route 53 to manage our domains. So we're not doing that separately from the DNS server. It's all added into one single component. For storage, there's all kinds of storage out there that Amazon will give us, AWS can give us. So S3 for object storage, EBS for block storage, EFS, FSX, we'll talk about those here in a few slides. Over on the right of the private subnet, for our databases, we have all kinds of choices there as well. So Amazon RDS, if we want to do relational databases, as we might know them, SQL-based databases, or maybe DynamoDB, and there's some others as well that we'll talk about in the next few slides. Amazon EFS is, I should have left it over on the left under the bucket. But again, that's a file service. That's a file storage system. All right. But we can still, over on the far right, you see, we still have our corporate network. So we can still tie into our on-premise network as we desire to do so. So on the bottom connection over there to the corporate network, we can do something called Direct Connect. And with Direct Connect, if we tie our premises to a Direct Connect partner, a DX partner, we can have a 1 gig, 10 gig, or even in some places, 100 gig dedicated connection into the components that are in the AWS cloud for us. Likewise, if we don't want to do the Direct Connect, we can still tie in our corporate network via the internet, via VPN. And that's the top picture there with the top cloud. Good markup there, Vic. Thank you for all that. So now there is one thing that's on this picture that you may already have in place, but something that AWS is extremely good at, and that is the auto scaling. So the auto scaling, sure, I can set up multiple servers, but it can also turn on auto scaling to where if the demand increases, we instantiate more servers. If the demand decreases, go ahead and do a click for me, please. If the demand decreases, then we can take those servers back offline and you're not paying for them if they're not in use. So there's just an example of how we can move everything over to AWS and actually take advantage of the fact that we have all these capabilities. And one of the things that we'll also learn about when we get into AWS training is a lot of these services there can be serverless. So in other words, AWS will manage all this for us. So all we need to do is say, hey, AWS, we want to do this. Can you help us? And they will manage it. We don't have to worry about operating systems. We don't have to worry about virtual machines. A lot of this comes already serverless, but a lot of it can also be serverless if we desire to do so. All right, Vic, back to you.
Thanks, Greg. Yeah, I think that's the big deal and the big takeaway there is that there isn't a whole lot that you can do with on-prem physical infrastructure that you can't instantiate as a service in the AWS cloud. So keep that in mind as you go forward, because one of the things for us as network engineers is that we've spent our careers investing in the knowledge and the understanding of all of these physical devices and how they work, whether they're routers or switches or firewalls or load balancers or NAT gateways or VPN concentrators. All of these things that Greg talked about are things that we deal with every day with premise-based services. And that investment in knowledge and skills that we use to configure those things is directly translated to what you can do with these resources in the cloud. So the big thing for us is to understand this new language of how you do things, how you access them, and how you instantiate these things without ever having to pick up a screwdriver or connect a cable, right? Which can feel limiting to some degree, but it's also somewhat liberating because you can do this all through a console or that console that we were looking at previously. So keep that in mind as we go through here. The console, I'm going to show it to you again in a live fashion. Gives us the ability to go in and just configure services as we see fit. Let's say if I were to ask you, and you could go ahead and put this in the chat window if you want, but if I were to ask you, if someone came down and they said, hey, why don't you go spin up a web server because I need to do some testing. Ask yourself how long that might take on-prem. And I know those of you who are running virtual servers and you have your hypervisors running and maybe you have an image already set up, you might say I can do that within a few minutes, right? But what if you had to do 100 or 1,000 of those things? Do you have the physical resources to do that within the next 15 minutes? Or is there something else that you would have to do? Maybe go through procurement, buy those things, or whatever. So bottom line is, if somebody comes to me and says, hey, I need you to spin up a web server, maybe Greg says, I need you to spin up a web server. I might whip into my console here, go over here to instances and say, hey, I'd like to launch an instance. And what Amazon says to me is they said, well, Vic, that's cool. You can launch an instance. How would you like us to launch it? What would you like us to use? And Amazon provides us with something called an Amazon Machine Image, or an AMI. And basically what that provides me with is a root volume, or a template for a root volume, and all of the parameters and libraries, et cetera, needed to launch a virtual machine in AWS. So you can see that those virtual machines could be Linux-based, they could be Mac-based, they could be different flavors of Linux, they can also be Windows-based. So you can, maybe you need a 2019 server or a 2016 server for your particular application, right? So we have a lot of different choices there. Additionally, if those aren't enough choices for you, you can go to the AWS marketplace and you can purchase or use AMIs that have been provided by different vendors. So for instance, if I click on, let's go to our favorite Cisco over here. Cisco has instantiated a lot of their appliance software on AWS AMI type images. So you can simply choose one of these and launch an instance from there. Let's go back to our wizard here. Let's go ahead and launch that web server. I'm going to select an instance, and the next thing I get to choose are the resources that that instance actually uses to run. And you'll notice that I get to choose between the number of CPUs I have, the amount of memory, et cetera. So basically the horsepower I have for that particular server for what I need. You'll notice there's some in here with 192 gig of RAM, right? So interesting stuff as we go through here. The next thing I get to do is decide which virtual private cloud to put my resources in. Remember, Greg described the virtual private cloud as your little slice of the network where you can do whatever you want in AWS as if you were within your own prem data set. I can decide which subnet to put that host in. And I can also tell AWS to give me a public IP address. And down here a little further, one of the things I can do is I can say, well, I'd like to launch a particular service, maybe a web service. So I'm going to go ahead, and what I'm going to do is I'm going to update my packages on my system, and then I'm going to go ahead and start the HTTP service, just that quick. I'm going to specify the size of my root volume. I can also add or mount additional volumes if I need to. I'm not going to do that because that'll take a little bit of time. Okay. It's always good practice to name your instances so that you can find them later. Just call it a demo for now. And then you can also secure your instances. So very much like you're used to doing today with ACLs, as well as setting up firewall types of rules, you can do this for your instances, your virtual machines as you bring them up in AWS. So here I'm going to add a rule. Since this is going to be a web server, let's make sure people can get to it over the web. And for those of you that are purists, maybe what I should do also is add a rule for secure HTTP, because you're probably paying attention to that. Okay. And again, I want to make it public. So basically, I get to review the changes I made. Okay, there's my security rules. And then I'm going to go ahead and launch that instance. And it's going to prompt me for a key pair. Again, this is for security, so I can remotely manage this resource. But after that, this instance is going to spin up. So it obviously took me a little more time than it would take you to walk into the data center and fire off an image off of one of your physical servers if you happen to have a snapshot of that thing running. But that said, I can do this with 1, 10, 20, 100, or as Greg said, I can auto scale, which I can turn on an auto scaling feature and spin up instances as I need to, rather than, and I can also turn them down depending on what the demand is on them. So around the holidays, I might need more compute. In the summertime, as we go into summer, maybe I don't need as much compute. I only have to pay for what I use. Notice here, I got my public address assigned. Okay. And it also appears my instance state I'm running. So let's open up a web browser here. Go ahead and paste that in there. It might not be quite ready because it's got to, remember I told it to patch and fire up that HTTP instance. So it might take it another minute or two, but let's see if it'll work. Yeah, it's not quite ready, but that's as long as it actually takes to bring up an instance in, or a web server in AWS land. So that guy's up and running now. All right, so the next thing probably to think about is a web service isn't a lot of use without some additional components behind it, maybe storage components or some database components. So Greg is going to talk to you about those now.
Hey, Vic, if you don't mind, just see if that hasn't booted up by now. I bet you it has.
Let's go. Okay, thanks, Greg.
Just refresh that. I bet you it's there.
Oh, there we go.
Ah, there you go.
Thanks.
So everyone, how long did that take? And of course, Vic was talking as he was doing it, but to me, that was pretty awesome that I can have a functional web server up and running in just a matter of minutes. So, all right. So as Vic was saying, of course, we can do web servers, but we also need to have those components where we can store data and maybe databases. That'll be on the next couple slides. So we do have a variety of storage options in AWS. The first one, and probably the most commonly known one, is on the very top there, Simple Storage Service, otherwise known as S3. This one is awesome. It's object-based, so we don't care what you put in there. And we don't care really the size as long as it's less than 5 terabytes for a single object. And if somebody has a single object that they're storing that's more than 5 terabytes, I'd like to know about that one. It is object-based storage, so we don't care about the data being structured. So you just put whatever you want in there. A lot of times we use S3 for videos or photos, things that don't change quite frequently, because if they do change, we need to replace the entire object. Look at the durability number there. That's 11 nines. And I forget the exact figures, but that's like if you have 10 million objects stored over a period of 10,000 years, which I don't think any of us will be around for, you might lose one. That's what those 11 nines represent. And you're already familiar with 99.99% availability. A lot of the stuff in S3 is automated. Backups. If you want to, you can turn on encryption. You can turn on versioning, so you can have multiple versions of files. And you can also turn on deletion protection. So if you're afraid that one of your other folks are going to go in there and accidentally delete things, you can prevent that. But as I said, S3 is pretty much the choice when you have objects that don't change very often. And as a matter of fact, if you have objects that are infrequently accessed, or you just need to archive things, there's also different tiers of S3 to allow you to pay less for those items that you're not going to be trying to retrieve all that often, or maybe you just want to have a place to park them. So that's S3 for objects. EBS on the bottom of the slide, Elastic Block Storage. You saw Vic just set up that EC2 instance. That volume that he was setting up, that was an EBS volume. So EBS volumes, that provides us with our block-based storage for EC2, right? So we can choose, we didn't really go through the options there, but we can choose different types of storage. So general purpose drives, provision IOPS, magnetic, in other words, regular old hard disk drives. And you can see the durability. I'm not going to go through all that. It does support automated replication. I can have up to 64 terabytes as far as the size of my volume, depending on the volume type that I chose. And something new with AWS when it comes to EBS is now we can do something called multi-attach. And that means that I might have multiple EC2 instances tied into the same volume. So I can either dedicate this volume to a single instance, or I can have multiple volumes sharing the same instance or the same storage instance. All right. Next slide, please. If you want file-based storage systems, then EFS, Elastic File System. As it says up there, NFS 4.0 or 4.1. And because it's NFS, this is designed for Linux-based workloads. But the good news about this one is not just EC2 instances. Other AWS services can tie into EFS, and also your on-prem services. Your on-prem servers can also tie into this EFS volume. Again, same huge amount of durability. It'll scale up and down automatically based on how much data you want to put in there, and you pay for the amount of data that's in there. And it is actually under the hood, it is object storage, and it's actually being stored on S3, but we don't really tell you that all that much. But the way that you get to it is the way that you would get to any NFS-based file system with your NFS protocols. And then finally, on the bottom, FSX. FSX comes in two flavors, one for Windows and one for Linux clusters. And if you're not familiar with Lustre, it's a very high performance file sharing system where we have clusters of Linux servers all processing away on the same data. We're all crunching away together. So in other words, again, cluster of Linux. So you choose. If you have a Windows system, then great. You do FSX for Windows, and that's going to be a good old server message block file protocol. If you have Lustre, then you use that version. It is fully managed, so this is one of those ones where I said that you don't need a server set up separately. This is just managed completely by AWS. And in AWS, we have something called regions. And then inside the regions, we have something called availability zones, excuse me, for redundancy purposes. And these FSX volumes will span across those AZs, those availability zones. So if for some reason there's a failure in one, your system is still working. And by the way, this is true for all the storage, all right? We can go across multiple AZs, all right? So that's some of our storage options. Next slide, please. Database. If you need a relational database system, then AWS offers Amazon RDS, Relational Database Service. If you're already using one of those engines at the top, on the top bullet there, PostgreSQL, MySQL, MariaDB, Oracle, or SQL Server engines, the cool thing is that's supported by RDS. So you can bring your databases over directly into RDS if you've already been using those types of systems. With RDS, it does run on an instance, but the instance is dedicated for the database. If you need more power, you can scale up that instance. You just go ahead and select more memory, more CPU. Or it can also scale horizontally, which means that you create multiple read replicas, maybe across multiple AZs, multiple availability zones, and that'll allow you to service multiple read requests, which if we've been working on databases, we know that a lot of the traffic is reading the information that's in the database. So as I said, we can increase CPU memory, even though we do have to run this on an instance. Patching is automatic for us. Maximum database size, 64 terabytes, unless we're using SQL Server, and then that's 16. And automated backups and user-initiated snapshots. So if you're at a certain point in time and you say, hey, I want to save this, just go ahead and go in there and set off a snapshot of it. All right. So that's for the relational. However, we also have something called Aurora. think of Aurora as RDS on steroids. All right. So Aurora, it's serverless version, so you don't use an instance. It will support either MySQL or PostgreSQL. And because it is supercharged, because it's serverless, because it's run inside the AWS magic domain, it's going to be many times faster than either MySQL or Postgre. Distributed across multiple AZs, fault tolerant, self-healing. It will auto scale up and down all the way up to 128 terabytes. And it will also allow you to have up to 15 read replicas located around the world, right? And as you might expect, continuous backup and point-in-time recovery. With Aurora, if your main system fails, you can switch over to one of those replicas, and it will be, you will lose milliseconds, maybe in the data. Next slide, please. If you don't need SQL, if you don't need a relational database, you just need a simple key value or document type database, DynamoDB. Super, super, super fast. As you can see here, tables virtually any size, can scale to more than 10 trillion requests per day or greater than 20 million requests per second. There's a large company out there that likes to use DynamoDB for their ordering system, Amazon, because it can support a massive number of requests. Right? It allows us up to petabytes of storage. If I don't like millisecond response time, I can turn on something called DAX, the DynamoDB accelerator, and that takes my response time from milliseconds down to microseconds. All right. Global replication is available if you turn it on. So this is not only in a single AZ, this is not only in a single region in AWS, but these replicas can be across regions, and they build what they call a global table. And as you might expect with this super speed system, point-in-time recovery, and you tell us when you want us to do backups and when you want us to do, or actually you do your own restores. But we can do on-demand backups, and then you choose when you need to restore. There's a bunch of others. I'm not going to spend the time going through them, but as you can see, and we are going to share these slides with everyone, there's other database solutions. If you want to do caching, Elastic Cache for either Memcached or Redis. And I'm not going to go through the others, but you can see there's a whole variety of database options, depending on what your needs are, that you should be able to find a solution for inside of AWS. All right, Vic, back to you. You're muted. There you go.
Hey, thanks, Greg. So why did we take the time to talk about database options? I thought we were talking about network engineering. But I don't know, when I put that abstract together, I said we were going to say something about DevOps in here, and I suppose we should say something about DevOps. And it's really the idea that you're bringing, it's not a new concept, right? DevOps has been around for years now. But it's really not a technology, but more of a methodology, right? Of bringing operations folks together with developers and the business to try to develop the most streamlined form of application development and delivery that we can for our customers. And there's hardly ever an application that's built these days that somewhere doesn't rely on a database behind it. So we just wanted to show you a little bit about the database support provided by AWS so that when you actually go in and you're talking about and thinking about your application challenges, your network infrastructure challenges, et cetera, you know that you have all of the underlying pieces for the infrastructure that are available to you, but you also have the application layer things. And if you're like me, you sort of started out your career at the top, at the desktop level, and you slid down the protocol stack down to where you're building cables in the end of your career. And the great thing about AWS is it allows us to get out of the basement and back up there to that application level. But yet we're building all of these things that we used to get in the data rooms and rack and stack and twist screwdrivers and connect console cables to, et cetera, to bring them up. Now we can do that all through this console. So what does that have to do with this slide and automation? One of the biggest things that I saw there on the poll that we did in the beginning was you folks said, you think about automation when you think about the cloud. And I think you're right, whether it's auto scaling, like we talked about, whether it's the ability to bring up resources quickly, it's one thing to go through. You saw that it could take some time to build that infrastructure that Greg went through with you, right? You have to configure each one of these components individually, create the relationships between them, and then go ahead and configure them and kick them off. And you can do that all through that AWS console. But the one thing to understand is that all of those things that look like physical devices on paper are just virtual functionality built in code that runs on servers, right? So not only can we build our infrastructure from code, but you already saw we can deploy our applications automatically. So I'm going to show you one tool, and it's only one that's provided by AWS, one of many, I should say, that gives you the ability to automate the building of your infrastructure. Because it's one thing to go through the console and maybe spend a half a day, build up that infrastructure and deploy a server. It's another thing if somebody comes to you and they say, hey, Vic and Greg, I need you to deploy that infrastructure 50 times in 10 different regions. So what we might consider at that point is using a tool like CloudFormation. And CloudFormation really is AWS's answer to providing infrastructure as code. Now we build something called a stack. And within that stack, we can build that entire infrastructure that Greg showed you with just a few clicks. I'll go in here, I'll say I'll upload a template file. I'll choose my template file. Maybe I'll build a network infrastructure, and I'll open that template file. And if you want to see what that template file actually looks like physically, or what it's going to build physically, there's a little GUI designer. This is because not all of us are programmers. And so we don't know necessarily how to read JSON code or YAML code, but we know how to drag and drop things. And we can drag and drop objects onto this palette. And here what you can see is that I've got a virtual private cloud that I'm building here. Inside that virtual private cloud, I'm going to build a subnet. That's this thing. Okay. And then I'm going to put some rules on that subnet, right? I'm going to say, hey, to get out to the rest of the world, take this route, right? And then down here, I have an internet gateway so I can route my traffic. So that's the infrastructure I'm going to build. And if you happen to be code crazy, and like to read that kind of stuff, you can see that this indeed is our infrastructure instantiated as code. So we wrote this code, and we're going to go and deploy it. YAML is a little easier to read, okay, in case you would like to do it that way. So, oops, I didn't mean to do that. I'm going to go ahead and hit this button here. And what that button is going to do is just take me back here where I can hit next. I can give this stack a name. I don't know what it's going to be called, demo. Okay. Now what it's prompting me for is actually the IP address space that I'll be using in that virtual private cloud. We'll go with an easier one that I can't mess up. So I'm going to use something from that RFC 1918 address space, right? The private addresses, because that's what you use in AWS land. You can also use IPv6 addresses, but those are harder for me to type. So I just subnetted my 10.0.0.0 network into a 24-bit subnet, right? And I'm going to go ahead and launch that.
And Vic, those parameters came from the script, right?
Yeah, I went ahead when I put that script together. I said, hey, I don't know where I'm going to deploy this, so prompt me for those addresses, right? So you can do that. You can have the script be interactive with you. And again, it's probably good to give it a name. And you can assign permissions here. I'm not going to worry too much about that right now. Do you remember what I gave that? Maybe I should do it this way. remember what I called that stack. I call it demo. Hang on. We'll find out later. Okay, go through here. There's my CIDR block range that I set up. Okay, we're going to go ahead and create that network stack. So as we go through here, it's called demo. That was creative. As we go through here, what we're seeing is we're actually seeing that network infrastructure being built for us. Again, no hands on the steering wheel. I didn't have to bring any racks in. I'm not turning any screwdrivers. I'm not opening any cardboard boxes. I'm just letting the stack get built for me, the entire network infrastructure. And notice what's happening here. It says, well, we're going to spin up an internet gateway for you. We're going to create a virtual private cloud to stick that gateway to. Okay, we're going to set up a subnet for you and a route table so that that route or that subnet can actually use that gateway. And as we go through, then we're going to associate that route table with that subnet and any of the objects that happen to be in there. That's incidentally one of the things that we didn't tell you is when you go ahead and build these subnets in that VPC, you get something called an implicit router. There's something inside there that actually routes between all the subnets that you create without you having to actually stand up a router on a stick or anything like that to do that stuff. And that's just pretty cool. Okay. And lo and behold, our infrastructure is now built. So that virtual private cloud, that entire infrastructure that we just talked about is done. Now, if I wanted to go through now and add an application to that, I very much could. I could go out there now and say, hey, go ahead and deploy a web server in that environment. And very much the same way as we did before, I can go out and just throw a web server in there. And what I did there, you notice it prompted me for the stack name. That's a way that you can tie two of these scripts together. So I could have put that web server all in the same stack and built that all at the same time, but I chose instead to say, hey, let's build a network stack in case that's something that I replicate all the time for other things. And then if I want to deploy different types of application servers into that type of network, I can without, and so that just gives me a way to decouple those two things. Okay. So anyway, I won't make you suffer through watching me bring up another web server, but what you can see here is that, whoops, I must have typed the name wrong. Oh, that's a nice thing to be able to see though. One of the things is if you have an error in your script, instead of messing up your entire network or messing things up, AWS is going to tell you about it and say, hey, I'm going to roll that back to where you started. Nice try, go try again. Okay. So with that, I think we're getting close to the top of the hour, and I want to have Kristen, give Kristen a little bit of time to talk to you about things. But does anybody have any questions, or did any questions come in the chat window that we should be looking at?
No questions yet. One thing I did want to point out, if you don't mind, Vic, to everyone, is just about everything that we've talked about today. The EC2 instance, a lot of the storage options, a lot of the database options, even I believe, well, yeah, of course, the code formation, as long as you're building certain items. If you're just getting started with AWS, you may have seen Vic when he was going through the demos, some of the things said free tier eligible. You get a year on a lot of these items. You get a year to go ahead and get in there, set them up, play with them, see how they work, as long as you don't exceed certain limits, to where you can play with them for free. So if you're new to AWS, sign up for an account on AWS and see what's available to you in what they call the free tier. Yeah, like that one there, the Amex, the Amazon Linux AMI. And then when he went to the next one where it said the instance type, the T2 Micro, right? So if you're not familiar with AWS, get in there and play. It's not going to cost you anything as long as you're careful to stay with the items that our free tier, and there's an awful lot of them. You'll be surprised. All right, thank you.
Okay, so hopefully, again, this gave you some things to think about, so maybe some things to think about within your own environments as far as, hey, I know one of the things I thought about when I learned a little bit more about AWS immediately was I have some aging servers. I have a server in my infrastructure that's probably 15 years old. It's got a RAID 5 array on it that's equally as old, and it worries me all the time. So really, you could probably imagine just from the things that we talked about here in this short session today, some of the things I could do to replace that server without spending any capital expense up front. I'm going to have to pay for it on a monthly basis or a recurring basis, but I can get that thing spun up and running in the cloud, right? Move my data over to it without having to go through that painful process of design and procurement approvals and all of those things to get a good backup up and running of that server. So I hope that gives you some idea of where we're at, and hope you enjoyed this session. Thank you, everybody. And please feel free to email us comments, or and we'll also get this presentation out to you as quickly as we can.
And I'll echo Vic. Thank you, everyone, for your time. I appreciate it.